So this probe demonstration uses a 3270 KICS application running on our Australian mainframe. You can see that application here just for reference. It's our small accounting application you may have seen in prior demos. We're going to use Probe to refactor this application from the mainframe to AWS Beanstalk here in the States. As we've discussed before, we're going to use a top of the pyramid approach to assemble these assets. So that's the application's KICS transaction definitions on the mainframe for an online application. We'll automatically refactor the COBOL code to the JVM and the vSAM data into a relational data store in Amazon RDS. This is Probe's main interface. I have it pre-configured to know how to connect to our mainframe, where to find and store files, and it's in automate everything mode. Obviously, all the steps you see could be executed manually and, as importantly, repeatably. It's going to run pretty quick, so I'm just going to describe what's happening as it goes. While this demo is fast, it does demonstrate very well the automation that Probe can provide and the potential to speed up application refactoring massively. So let's start the process. Probe is connecting directly to the mainframe, retrieving and analyzing those KICS definitions, and then looking for dependencies. In this case, the programs invoked by the transactions. Probe will find that we don't have that code locally, so it will now reach back to the mainframe and download the source code automatically. It will then loop around, doing that again and again, analyzing each new set of assets and downloading other missing programs, copybooks, screen definitions, everything that makes up this application. The goal here is to collect the entire set of application assets up front, rather than discover missing assets midway through a project. It will then download all the vSAM file metadata, their layouts, primary keys, alternate indexes, everything we need to know to transform those files into a relational database. So this is now cutting out weeks, months of project time. Rather than gather that data for hundreds of files manually, we can automatically collect that crucial information and then, as you see here, construct DevOps scripts that can automatically migrate those files whenever we want, repeatably. So that's what Probe's doing now. We're automatically migrating our vSAM file from the mainframe into a table in Amazon RDS. That gives us not only excellent scalability for that data, but also access for other applications via standard SQL views. Once the data is migrated, we turn to the application code itself and again construct and run build scripts that will invoke our compiler and refactor the application. So again, that's what's happening here. We're constructing Gradle scripts to do that work so that this becomes a repeatable DevOps pipeline process that can be run anywhere at any time. It's compiling, it's packaging the application, and then it's deploying it, in this case, to Amazon Beanstalk. So let's go take a look at that Beanstalk. So this is the Beanstalk interface. We're going to have to give this a moment to update itself. It's taking that WAR and it's distributing it around the Tomcat nodes in the cluster. So while it does that, let's recap. We started with the KICS application definition on our mainframe, automatically analyzed, assembled, and refactored both the code and the data to AWS. So let's take a look at that application. And here it is. Out of the box, we create a browser-based application from the original mainframe one. This retains all the look and behavior of the original 3270 app, which makes the move for users incredibly seamless. And of course, the data here is being pulled from that AWS database we migrated the vSAM file to.